transportation problem. We are going to find the initial feasible solution of a transportation problem by Vogel's approximation method. So we have taken this problem and we have to solve. That means we have to find the initial feasible solution by Vogel's approximation method. So first we have to check the given transportation problem is balanced or not. How to check the given problem is balanced or not? Simply add the supply and demand. If both are equal, then given problem is the balanced transportation problem. So check 6 plus 1 plus 10 equal to 17, and now your demand is 7 plus 5 12 plus 3 15 plus 2 equal to 17. That means supply equal to 17 and demand equal to also 17. That means the given transportation problem is a balanced transportation problem. Now we have to find the initial feasible solution by Vogel's approximation method. We have already discussed about how to find the initial feasible solution by the Vogel's approximation method. So we directly proceed how to find. So first method, in this method what we do actually, first find the smallest and second smallest in row wise and take the difference. So in first row, smallest is the 2 and second smallest is 3, and take the difference of these two. That means 3 minus 2, that means 1. That is called the row penalty. So like the row penalty is the here 1. So in this case, in this second row, smallest 0 and second smallest is 1, and difference is the again 1. In third row, two smallest are the 5 and 8, and difference is the 3. And do the same process now in column wise. Smallest and second smallest, and difference between these two are the 1. And again in this case 0 and 3, so we get the 3, that is called column penalty. And again in this case 2 smallest are 6 and 11, so penalty is the 5. And in this case 1 and 7 means 6. After writing all the row penalties and column penalty, we have to choose which one is the maximum. Which one is the maximum in these 1, 1, 3, 6, 5, 3, and 1. So obviously 6 is the greatest penalty. So in this case we are getting what when we are getting the 6 in column. So we have to select the column. In this column we have to allocate as much as possible. So after selecting the column, see which one is the minimum cost. So obviously 1 is the minimum cost. So in this cell you have to allocate as much as possible value. So your demand, your supply is 1 and demand is 2. So yes, this cell can get the 1. And after that, update everything. So now your supply is done, so that is now finished. So simply update. Your 6 is remain, your 10 is remain, and now your 1 is finished, so 1 is remain, and your 3 update everything same, 5 and 7, and this one, this row has been now cancelled out. So after updating the table, repeat the process again. Repeat the same process again by row wise, but except this row, as this row is now finished. This row has finished supply. So now again in this row, the smallest and second smallest and difference, obviously we get the same value 1, and this has been now finished. So just forget about it. Now in this case, obviously we get again 3, and now same process repeat in column wise. So this has been finished. So only these two remain. So obviously difference is the 3, and here the difference is the 5. Here difference is 4, and here difference is 2. Again choose which penalty is the maximum. So 1, 3, 2, 4, 5, 3. So now 5 is the maximum. So that means again in column 1. So in this column, now choose which one is the smallest cost. So now 3 is the smallest cost to this cell. So allocate as much as possible to this cell. So your supply is 6 and demand is 5. So obviously this cell can get the 5. Now update everything, so that will be the now cancel out. Now your 5 is here, so 1 is remain. This I think already cancelled out. Here 10, and now here 5 has been cancelled out, so that is cancelled out. So now update everything, so that is again 7, and here 3, and here 1. Again repeat the same process after updating the table. Repeat the process again. That means again row wise, this column is finished, this row is finished. So now again row wise, in these 3, which 2 are the smallest, so 7 and 2. So now difference is the, in this case now 5, and in this case this has been finished. So only obviously this has been finished. So here this has been cancelled out. Now 5 and 9 are two smallest, so difference is now 4. Again do the same process in column-wise. This has been 8, so now 2 and 5 again 3. And this has been cancelled out, so now forget about it. In this case, we are getting the 4 again. In this case, 7 and 9 we are getting the 2. So again, check which one is the maximum penalty. So 5, 4, 2, 4 and 3. So now 5 is the maximum. 5 is the maximum. So now go ahead, we have to allocate. And here 1 is the supply, and 7 is the demand. So yes, this cell can get the actually 1. So now this side also finished. So that is the cancel out. This side already been cancelled out. And update everything after getting this is the 6 element that has been cancelled out already. And here update the 3, and here update the 1, and here update the 10. So which one is now cancelled out? So this has been cancelled out. This has been also cancelled out. So now this 2 row has been cancelled out. This column has been cancelled out. So only this row has been, only these 3 cells. So we can now allocate directly. As we can now here directly allocate everything. So now we 6 is remain. So simply allocate this 2 row has been cancelled out. This column is cancelled out. So only these 3 cells remain. And what is the remain supply is the 6. The demand is the 6. The supply is 10. Obviously you can get the 6. And this has been cancelled out. Here you can get the 3, and this cell can get the 1. And after that, now check everything is okay now. So now by row wise, 1 plus 5 equal to 6. Here the 1 equal to 1. Here the 6 plus 3 plus 1 equal to 10. Check the column by demand. So 1 plus 6 equal to 7, 5. That is the 5. Here 3 and 1 plus 1 equal to 2. So now this is the required initial feasible solution, which cell are the x11, x12, x24, x31, x33 and x34 equal to 1 is the required initial feasible solution of this transportation problem. We had to find by the Vogel's approximation method. So by Vogel's approximation method, this one is the required initial feasible solution of the given transportation problem. How to find the optimal solution? We have to check the optimal by the affirmative test. The given initial feasible solution is optimal or not. And then if solution is not optimal, then you have to find the optimal solution also. So we'll talk about the in upcoming videos how to find the optimal solution of this transportation.